Hello, I'm Alex Gonzalez, and this is lab number 2. So the purpose of this lab was to give a more accurate representation of the charge of a piece of tape. In the first lab, we treated each piece of tape as a point charge, but in this one, we're going to be treating them as a line charge. So the physics principles that we used in this lab were Newton's second law, Coulomb's law, and the electric field created by a charged rod equation. So some data I found was that the charge in lab 1 was 7.3 times 10 to the negative 9th, whereas the charge in lab 2 was 2.19 times 10 to the negative 8th. This is due to using a different equation to find the charge, and in lab 2 it's probably a more accurate equation for the given scenario. All of the other values found in the experiment portion were the same, however. So the code for this lab ended up giving a more accurate model of what actually happened in the experiment. In lab 1's output, you can see we only used 2 point charges to show what was going on and 2 force vectors. In lab 2, though, we had 20 of each point charge lined up with each other to show that is what the piece of tape actually looked like. And we had electric field arrows in this lab as well to show how each individual point charge was getting an electric field from the other point charge. So at the top, I created an electric field function to get the electric field for each particle that you sent to that function. And in the second box, I added each of those electric fields found to the electric field variable and then multiplied it by a charge to get the actual electric force of the at that point. And at the final box is where I created the 2 force vectors and multiplied them by a scale so that they would more accurately show on the screen. So some questions that were asked in the lab were, what was the magnitude of the charge of one piece of tape as calculated by your model? This was 6.18 times 10 to the negative 8th coulombs. I had to guess and check a few times in order to get this value in which the electric field force and the gravitational force were equal. This is different than the actual calculation I found in the experiment, which was 2.19 times 10 to the negative 8th. And most likely this is due to having only 20 charges in the code, whereas if I had the computational power to do thousands of them, it would be probably more accurate than that. And what are the assumptions, approximations, or idealizations you made in the lab? And we ignored air resistance, which most likely had a big effect because in my room specifically, the vent pushes pretty hard and it most likely had an effect on that top piece of tape. And we assumed that each tape had an even distribution of charge, which most likely was not the case. There were probably not an even distribution, which would have caused a different result. And if we modeled the tapes as a point charge in this lab, we would have gotten the same result in the first lab, where it was 7.3 times 10 to the negative 9th coulombs, instead of the 2.19 times 10 to the negative 8th coulombs we got in this one. And these estimates differ because to show this, you can think about it like a Riemann sum versus an integral. A Riemann sum will find the area under a curve, but it won't be as accurate as an integral because it won't find those tiny slivers that all add up to equal the area, which the actual equation for a line charge is actually the integral of the point charge equation. So like the code, it is adding up a bunch of tinier charges to get the final charge.